Welcome, this is Dr. Amanda Rackinson ZabQ. In this tutorial, we're going to focus on variables. I will note that this tutorial is split into two parts, and this is part one. In this tutorial, we are going to do three things. First of all, we are going to define variables. We are then going to talk about two different types of variables, and then talk about the four levels of measurement. In part two of this tutorial, we will talk about identifying variables. Specifically, we will talk about labeling them and also defining them operationally. Let's first define the term variable. Research studies in social science and education are conducted by collecting data on one or more variables. Then, statistics are used to analyze these variables. So, a variable can then be defined as any condition, characteristic, or entity that can take on a value, or can take on different values. Examples of variables are broad and wide. Some examples of variables may include race, a course grade, or the degree of self-efficacy. As variables are foundational to statistics, it's really important that we understand the term variable. So we're going to take a little bit closer look at it. As you remember, we just defined a variable as a condition, characteristic, or entity that can take on different values. Now, a value is any number or category. A variable can take on any number of values. It varies. And it depends on the type of variable that it is. Values can be categorical, or they can be words such as never or always, or they can be numbers like 10, 5.5, or 23.5. Usually variables have a predetermined range of values that they can take on, and I'm going to explain this further in practical terms in a minute. But let's go ahead and finish defining important terms. Our last term is score. A score is an individual value. It is the value that is observed for one and one case only. Another way to say it or to think about a score is it's a particular individual's value on a variable, their observed score. Sometimes you will see also in statistical text the term score referred to as observation or rating. Now let's put this in more practical terms. Let's say that a researcher desires to know if students enrolled in a residential college statistics course have higher course points than students enrolled in a similar online statistics course. Let's go ahead and focus on the variable that the researcher desires to affect, course points. What we can say is that course points is a variable. It's an entity that can take on any certain range of values. At this specific university where this researcher works, the number of course points earned can range anywhere from 0 to 1,000. That is, the values for the variable of course points can range anywhere from 0 to 1,000 points. Now that we've identified the possible range of values, or the possible values that the variable course points can take on, we can examine individual students within the course. Looking at the instructor's gradebook, we can find that online student A earned 1,000 points, and online student B earned 800 points, residential student A earned 950 points, and residential student B earned 850 points. So, for example, 850 points represents one score. That is, it is the number of course points that one student earned. So here we put in practical terms the term variable, value, and score. Now that we understand the term variable, we can talk about types of variables. We can distinguish between two major types of variables: quantitative variables, which are numeric, such as test scores and height, and qualitative variables, which are non-numeric or categorical, such as sex, political party affiliation, or type of treatment. Let's go ahead and define qualitative variables further. As I just said, qualitative variables are non-numeric or categorical. They are variables whose values are categories. I just gave you an example of this, but let me give you another example. Types of course is an example of a categorical or qualitative variable. The type of course has two categories: residential and online. Qualitative variables, it's important to note here, cannot be put into any meaningful order. Then we have quantitative variables. Quantitative variables, as I said before, are numeric, or they're variables whose values are numbers. Because they are numeric, we can put them into meaningful order, and they can give us information about the differences between two variables. There are many different types of quantitative variables, and examples of these again include test scores, height, and weight. There are actually then two types of quantitative variables. There are discrete and continuous. Discrete data is counted and continuous data is measured. Discrete variables are those which have specific values but cannot have any value in between. For example, a teacher can have 30 students in her class, but she can't have 30.5 because she can't have half a student. Discrete variables are also are thought of, like I said, as countable for this reason. Remember, I said discrete data can be counted. Then there are continuous variables. Continuous variables, on the other hand, can theoretically have an infinite number of values between any two values. More practically, this means that a person can record a score on a continuous quantitative variable of, let's say, 30.456 and so on. A person's height could be a value within the range of human heights, that is, not just certain fixed heights. Time in a race, you could measure it in fractions of even seconds, so those are considered continuous variables. So let's think back to our example. And thinking back to our research example, are course points discrete or are they continuous variables? Well, the answer to this question really depends on how the instructor grades. But let's say for this example, he or she uses decimal points. Therefore, we consider the variable course point or course points as a continuous quantitative variable because it is possible to have a score ranging anywhere from 0 to 1,000. So a student in the class could have the course points of 832.50. Maybe an even better example of a continuous quantitative variable may be height or duration of a class. Duration of a class is considered continuous because a session could last for 60 minutes, or it could last for 61 minutes, 35 seconds, and 11 milliseconds, depending on how precise the teacher actually wants to get. Now that we've taken time to identify the basic types of variables, define them, and talk about practical examples, we are going to move on to look at what are called levels of measurement. Remember that a variable can take on different values that give us information about what we are measuring. Some variables, like qualitative variables, contain less information about the difference between two values than, let's say, quantitative variables. These differences are reflected in what we call the 4 levels of measurement. Now, a variable's level of measurement is very important as it has implications for the type of statistical method used or type of statistical methods that we will use and we'll look at in later tutorials. I will note here, however, some statistical texts say that you only need to understand the 2 types of variables to make decisions about statistical methods and not all 4 levels of measurement. However, individuals like Warner and it really dates back to Stevens say that you need to understand the levels of measurement. So we're going to talk about them here. Now, variables are typically measured on 4 different levels of measurement: nominal, ordinal, interval, and ratio. And we're going to take an in-depth look at each of these. We're going to start with the nominal level of measurement. The word nominal is actually based on the Latin root for name, which will help you remember that these variables represent names or categories. Nominal variables are variables that can be qualitatively classified into discrete separate categories, and these categories cannot be rank ordered. Some examples of nominal level variables include religion, groups, affiliations, and type of treatment. Let's take, for example, religion. Religion can, individuals may be sorted into different categories of religion: Christian, Jewish, Islam, and other. In experimental research, oftentimes there are different types of treatment, and individuals are put into either a control group or a treatment group. Now, when analyzing data, especially in SPSS, sometimes the researcher may decide to use numbers to represent the categories in a data set. Like coding, let's say we're classifying things into different colors. So let's say we have red and blue, and red is labeled or coded as 1 and blue is coded as 2. It's important to remember that this does not change the level of measurement. The variable of color is still nominal because we have two categories, blue and blue is not greater than red, and red is not greater than blue. So it's a categorical variable. Now we move on to the ordinal level of measurement. The ordinal level of measurement gives us information about the values of a variable because the values can be put into meaningful order. However, the real distance between each value is not the same. Ordinal variables are variables that can be qualitatively classified into discrete, separate categories, just like our nominal variables. But additionally here, they can be rank ordered, unlike our nominal variables. Thus, with ordinal variables, we can talk in terms of which variable has less and which variable has more. However, we cannot distinguish, as I said, how much more or how much less. Let's take a look at some examples. An example of a ordinal variable is how individuals rank or how runners rank in a race. The difference between the first and second place winner of a marathon may be 35 seconds, while the difference between a second and third place runner may be 2 seconds. The values first, second, and third of the variables or place in the race can be placed in meaningful order, but as we can see, they do not represent the same real distance between them. Additional examples of ordinal variables may also include socioeconomic status of families. We have high, medium, and low. Age, between the age of 20 and let's say between the age of 20 and 60, over 60 and below 20. It could include military rank or class rank such as freshman, sophomore, junior, and senior, or even ratings such as excellent, good, average, and below average. And although there is some disagreement about this one, IQ is also often considered an ordinal scale variable. I should also take a moment to note here that although Likert type scale data on many surveys is ordinal because individuals are asked to rank questions such as agree and strongly disagree or they're neutral, educational researchers actually treat Likert scale data in their research as more interval or ratio data for the purpose of analysis. And so we're going to talk about next ratio and interval data. So let's start by defining interval variables. Interval variables are variables that can be qualitatively classified into discrete separate categories just like our nominal and ordinal variables. They can be rank ordered just like our ordinal variables, and they are measured. In other words, interval variables can be put into meaningful order and the real distance between each value is exactly the same. Thus the term equal interval. Temperature, as measured in Fahrenheit or Celsius, is probably the most common example used for an interval scale. The distance between 36 and 37 degrees Fahrenheit is the same as the difference between 98 and 99 degrees Fahrenheit. We can also say that the temperature of 40 degrees Fahrenheit is higher than the temperature of 30 degrees Fahrenheit, the rank of it, and then we can go on to say that the increase from 20 to 40 degrees Fahrenheit is twice as much as the increase from 30 to 40 degrees Fahrenheit. That's measurement. However, variables at the interval level of measurement have an arbitrary zero rather than a true zero or an absolute zero. And since there is no absolute zero in our temperature example, we cannot say that the increase is twice as high. This is important in order to distinguish interval variables from our last level of measurement, and that's ratio variables. So let's talk a little bit about ratio variables now. Ratio variables have all the characteristics of all the preceding variables. In addition, though, they have a true or absolute 0 point on a measurement scale. This absolute zero indicates a total absence of what's being measured. Thus, we can not only talk about the difference between the two values, but here we can also talk about the magnitude of the difference. A scientist can say that one value of a ratio variable is twice as large as another value, or that one value is a fourth of another value. This is the only type of variable for which this is true, and the name ratio is derived from the fact that we can talk about these values in terms of fractional amounts. Examples of ratio variables include things such as pounds, or weight in terms of pounds, height in terms of inches, distance, let's say, in terms of yards, or speed in terms of miles per hour. Now that we understand, or we've at least defined the different levels of measurement, let's go ahead and make sure that we fully understand them by taking a look at a flow chart and some practical examples. When teaching her statistics course in psychology, Dr. Cox at Liberty University discusses a flow chart for determining how to identify the level of measurement of a variable. Here we see her flow chart and how it outlines the decision process. The steps are listed across the top and the levels at the bottom. I want you to take a minute to look over this flow chart before we move on. We are going to learn how to use this chart by stepping through a detailed example. Now that you've had a minute to review the flowchart, we are going to talk about an example and then we're going to apply the flowchart to this example. So the researchers are interested in knowing if students enrolled in a residential college statistics course have higher course points than students enrolled in a similar online statistics course, recognizes that there may be several other variables that affect the relationship between the two variables of interest, the course points and type of course. So he's interested in collecting data on them. Specifically, he's interested in collecting data on students' class rank because he recognizes that let's say freshmen may perform worse than sophomores, and he's also interested in collecting data on the hours that students spend studying because he knows there's research that exists that says the number of hours or number of minutes that a student spends studying can affect their course grade. The researcher is also interested in gathering some demographic data so he can describe a sample. Two pieces of information he decides he needs to collect is students' date of birth and then also their gender. Prior to running the data analysis, the researcher wants to fill out the table shown here with the levels of measurement for each variable. So then he can later describe his variables, and so he can also make a good decision on what type of statistical method to run. Let's start with the variable gender. We see that the different values for this variable are male and female. So looking at the flowchart, we begin with step 1 and ask the question, can the value of gender or the values of gender be sorted into categories? And we can say yes, they can. One category of gender is male and the other is female. So on to the next step, step 2. Here we ask the question, can the values be put into meaningful order? For example, can we order them from smallest to largest or least to greatest? Well, as you can see, that wouldn't make any sense because we can't say that males are better than females or higher than females or smaller than females, or vice versa. So our answer to this question is no. So following the no arrow, this shows us that the variable of gender is nominal. The next variable we are going to consider is class rank. The values of our variable class rank fall into 4 categories: freshman, sophomore, junior, and senior. So in step 1, when we ask, can values be sorted into categories, we can say yes. So we move then on to step 2. In step 2, we ask, can values be put into meaningful order? Well, let's consider this. Sophomores represent a lower class rating than juniors, whereas seniors represent a higher class rating than juniors. So our answer to step 2 is yes. Our values can be put into meaningful order. So then we move on to step 3. In step 3, we ask if there is a real difference between each possible value and if the real difference is exactly the same. In other words, is the difference between class rankings what makes the difference between a junior and a sophomore, are they equal? Are they the same? Well, let's go ahead and consider this for a moment. Let's say that sophomore A completed 30 hours, and let's say freshman A completed 5 hours, whereas the junior A completed, let's say, 56 hours. There's not an absolute distance between the number of credit hours completed that distinguishes a student as a freshman, sophomore, or junior. So our answer to step 3 is no. It then follows that the level of measurement for our variable class rank is ordinal or rank order. Now we move on to the variable of date or date of birth. We know that dates can be sorted by day, month, year, etc. So, since this is the case, when we ask can values be sorted into categories, we can say yes. Dates can also be put into meaningful order. For example, March 1st, 2013 is earlier than April 1st, 2013. So, when we ask the question can values be put into meaningful order, our answer to step 2 is also yes. We then move on to step 3. And remember, our question in step 3 is the real difference between each possible value exactly the same? Here again, I think we can answer yes. So let's think about why this is. Because each day lasts for the same amount of time, there is the same difference between June 1st and June 2nd as there is between December 10th and December 11th. So we can say yes to step 3. We then move on to step 4. And the question in step 4 is the difference between each value the same, and is there an absolute 0? Now let's think about a calendar. Remember, the calendar date 0 is arbitrary and does not represent the beginning of time. In fact, the Roman, Mayan, and Chinese calendars all begin at different times. So really, there is no absolute 0 here. So we can see that this variable date is an interval data level variable because it does not have an absolute 0. The last variable we are going to consider is time spent studying, and we're going to measure this in minutes, or our researcher is going to measure this in minutes. As you've probably already guessed, our last variable is at the ratio level of measurement. Let's go ahead and look at why this is true. The values for time spent studying are numbers, so we can put them into categories 1, 2, 3, 4, 5, and 6. They can also be put into meaningful order. 2 minutes is better than 1 minute, or 30 minutes is not as good as, let's say, 60 minutes. Or we can say that 30 minutes is less than 60 minutes and 60 minutes is greater than 30 minutes. So they can be put in meaningful order. So our answer to step 1 and step 2 is yes. Next, let's ask about or consider the distance between each value. Is it exactly the same? Well, let's consider this. The difference between 1 minute and 2 minutes is the same as the distance between 30 and 31 minutes. So our answer to step 3 is also yes. Now, at step 4, we have to ask ourselves if there is an absolute 0. In other words, is there such a thing as absence of time? Well, yes, theoretically, a student could spend 0 time studying. So we can answer yes to step 4. Thus, the variable time spent studying, measured in minutes, does have an absolute 0 and can be considered a ratio level variable. Now we can complete the table for the researcher as we have determined the level of measurement for each of our 4 variables. Gender is nominal, class rank is ordinal, the date of birth is interval, and time spent studying measured in minutes is ratio. Understanding the level of measurement for each variable, the researcher is now more familiar with his data and will be able to make informed decisions about what types of analyses he can run. Now, let's go ahead and talk about more specifically, even though I've alluded to it, let's talk about more specifically why levels of measurement are so important in statistics and why they're foundational. First of all, the level of measurement of a variable is important because it tells you what kind of data is contained within the variables that you're studying. And this in turn will help you describe your data accurately to other researchers using commonly accepted vocabulary. Second of all, the level of measurement affects what kind of statistical methods you use to analyze your data or can use to analyze your data. The statistical method available for analyzing ratio and interval level variables is different from those available for analyzing nominal level variables. So it's important that you understand what kind of variables you're dealing with before you can decide what you're going to use or what you're going to do with them or how you're going to statistically analyze them. So now that we've defined variables, talked about the two types of variables, and also talked about levels of measurement, this concludes part 1 of our tutorial on variables. Again, in part 2, we'll look at identifying variables and also operationally defining them.